So to begin, let's talk about what is an earthquake. An earthquake is the vibration of the earth produced by the rapid release of energy in a lithosphere. So we're talking about the outermost crust of the planet and the top part of the mantle, and that'll store up energy, and then that energy gets released rapidly, causing a shaking, and that's what an earthquake is. Most of the time, these earthquakes are along faults, and these faults are a fracture in the earth. So you can actually see here is a pretty good example of what a fault would be. And you can see that fault line runs here. And what would have happened is this side of the plate and this side of these would have moved around, and that's what an earthquake is. Now, when we talk about earthquakes, you'll hear two terms an awful lot, and that's epicenter and focus. The focus is here, and that's the actual location of where the slippage occurred. That's where the earthquake happened. That's where we had the plates move. Now, directly above the focus on the surface of the planet is where we find the epicenter. And the epicenter is what we're more concerned with because that's where we would look for the strongest amounts of damage. It's the place on the surface closest, and since we live on the surface, that's what we're concerned about. But remember, the focus is where it actually happens. The epicenter is that part on the surface right above it. Now, the cause of earthquakes, our current theory is basically the elastic rebound hypothesis. And that means that we've built up energy and suddenly that energy is released, and that's what causes the earthquakes. If we look at our picture here, we see in the first illustration, this one right over here, that everything's kind of normal, life is good, nothing big going on. But we'll notice in the second one that there's movement. This plate is moving this way, this one's moving that way. We see that movement, and we see that bending in the road, and we see that it's kind of stretching, and it's adding that, like stretching a rubber band. You're putting a lot of energy there. And then suddenly we have slippage or the earthquake here, and you can see that this plate's shifted this way and this one's shifted that way. And that's what causes an earthquake, is this buildup here of this pressure and then the sudden release. In the next video, we'll show you how we measure earthquakes, but normally what we'll see is we'll see a little device that's going to come through and it's going to measure the shaking of the earth like so, and that's what we end up with. And the reason I wanted to do this is I wanted to show you what these terms are. We talk about a foreshock, and a fore is before. So our foreshock here is going to be this one right here. It happens before we have the big earthquake occur here, and then we have aftershocks, which are going to come afterwards. These aftershocks and foreshocks are going to be smaller than the earthquake, but they can still do a lot of damage. Okay, well that's it for this video. As always, good luck in the lessons and the quizzes, and we'll see you in the next video. There are three types of seismic waves, and here we can see the first two of them. The first one is the P waves, and these are the fastest. And the P waves are going to travel in a back and forth motion along the surface. They can cause the ground to buckle, but the particles of the ground are going to move in the same direction the wave is moving. So it is a longitudinal wave. And you can see here that a wave is going to be traveling this way, and it's going to cause everything to kind of shimmy and shake back and forth as it goes through. And remember that the P waves, these are the fastest of the waves. Next up are the S waves, and the S waves are going to travel fast, but they're not as fast as the P waves. And the S waves are a transverse wave, and what you notice here is that the ground is going to move up and down as our wave is traveling this way. So this is what causes the ground to shake up and down. The P waves kind of had a shimmy back and forth. The S waves are going to cause it to go upwards and downwards. Now the third and final type of seismic wave are what we call surface waves. And surface waves are what's going to travel along the surface that we can see, and this is what causes most of the damage. One type is going to cause the ground to move side to side. The other one is going to cause it like a rolling, like the oceans, and you can see that here. And this is what causes a lot of deformation of the crust and the shaking, and what causes most of the damage that an earthquake does. Now we measure earthquakes using a device called a seismograph. And the seismograph is going to be attached down inside of the bedrock, and then it measures, right here you can kind of see a pen and it's kind of hanging, and when the earth moves, that's what's going to cause this drum to move, and as the drum is rotating and the earth moves, it causes that pen to swing back and forth. And that's where we get our stereotypical earthquake drawing that's going to look like that. Now a seismogram is going to be the actual picture, and we see one here. And notice we have the earlier time progressing this way to a later time there. we mentioned that P waves are the fastest, so they're going to arrive first. Then the S waves arrive, and then we have the surface waves, which are going to cause the most damage. So you can see how the wave amplitudes are going to be a little bit bigger, and we'll notice that most of the damage is going to come this one, which is a little bit slower. Now, normally the time between these isn't fast enough to give you a warning that we have one coming, but it does give you a slight advantage there that you know something's happening. We have three different ways of measuring earthquakes. We've all heard of the Richter scale. That's the most common one. That's what we still see on the news. And this quite simply measures the height of the largest seismic wave. So if you look at our little drawing here, they kind of determine how tall this is, and that's what we'll measure as the Richter scale. That's been replaced by the moment magnitude scale. And this one here looks at the amount of displacement along the fault, which can or cannot be easy to get. Sometimes we can't. And then a third type that we're using now is the Mercalli modified scale. And this one is done by seeing the extent or the intensity of the earthquake. So the lessons will go through all these three and explain them a little bit better. I just wanted you to know that there's three different ways we measure earthquakes now. Okay, so let's discuss how we find the epicenter of an earthquake. In order to do this, we go back to what we've already learned, and we learned that the P waves travel faster and they arrive before the S waves do. By measuring the amount of time between these two, we can calculate a distance to the epicenter. And if we take three different stations, and we'll look here, we have station A, and we know that it was 9,658 kilometers away, so we can go out that distance and we draw this red line. If we take station R over here and do the same thing, we can draw this purple line. And if we take station C, we draw this blue line. Now, the reason we use three stations is if we only use two, let's say we just use this A and R one, then we notice that they'd intersect here, but they also intersect over here. So we wouldn't know exactly where it is, but adding that third station shows us that our epicenter is going to be right here. Now remember, the epicenter is that point on the surface above the fault. So we don't know exactly where the earthquake was, but we know it's below where that epicenter is. Okay, so that's it for our video. They'll explain all of this in a little more detail in the lessons. Good luck on your quiz, and we'll see you in the next video. So earthquakes can cause damage in a number of different ways. Perhaps we're most familiar with this one here, the seismic shaking. And that's just going to be the shaking of the earth is causing damage to buildings and structures and things of that nature, and it's just simply that shaking that happens when that pressure is released in an earthquake. We also have a process called liquefaction. Liquefaction is when you have water-saturated soil and rock, and when that shaking kind of turns it into a liquid. So it's kind of like a muddy, solid rock you would think initially, but when you shake it all up, it kind of loosens up and kind of goes into a liquidy there, and that can cause damage. We also have landslides and mudslides, which can occur, and then we also have the big one down here, the tsunamis. And tsunamis are often called tidal waves, but they have nothing to do with the tides. Rather, tsunamis are caused by that rapid release. It's kind of like if you jumped into a pool and made one big wave, that's what a tsunami would be. Out in the open ocean, the way that we measure them is by speed. They're very, very fast, but they're not very big waves. They don't get to be a big wave till they move this way and towards shore, and as they get compressed in with the bottom coming up, it causes the top of the wave to rise up until we get this massive wave we call a tsunami. But we can measure them by speed, and there's a series of buoys throughout the Pacific that measure for these after an earthquake. So how can we reduce the damage caused by an earthquake? Well, the damage is going to depend on the strength and duration, so how strong that earthquake is and how long that shaking goes on. And that's what's going to determine how much damage occurs. But we can take steps to reduce that damage a little bit. If we look at where earthquakes happen, then we try and avoid putting large cities and building structures on the faults. That'll reduce the damage that would occur there. We can also have building materials or build structures that are designed to withstand that shaking a little bit. And also we can teach the populations that are there how to react when an earthquake occurs. So the combination of all of these preparatory steps will allow us to kind of reduce that damage a little bit, but we really don't know when the next earthquake's going to happen. So that's it for this video. Good luck on your quiz, and we'll see you in the next video.